Welcome to another Mathnificent conversation featuring order of operations. It's your nerdy math bestie Lex. Grab your pencils. Let's go. Before we get started, we're going to start with some background information, which we call mint green tea. Order of operations is the order in which you perform mathematical operations. So we know in math, there isn't room for ambiguity. The answer is the answer. So there are rules that have to be followed so that we all reach the same answer in the end. So one of those set of rules that we follow are order of operations. That means when you have an expression that has multiple operations, they need to be performed in a certain order so that you're arriving at the correct answer. A lot of the times people lose countless points because they do not have order of operations. Not necessarily that they don't have them memorized, but they don't understand the order in which the operations are performed. So most of us either know PEMDAS, please excuse my dear Aunt Sally, or you might just have the operations memorized in order. The key with PEMDAS, and please excuse my dear Aunt Sally, are these two lines here. So we start with parentheses, we move to exponents. Multiplication and division are together. Multiplication does not come before division. They are grouped together on the same line. Same with addition and subtraction. They're grouped together. Addition does not come before subtraction. Addition and subtraction are one step in PEMDAS. We're going to go into more detail, but they are performed left to right. So left to right, left to right. Which means if I'm left with multiplication and division, whichever comes first, you perform in order. That's what it means to go left to right. Same with addition and subtraction. Once I'm only left with addition and subtraction, because in order it would be last, I move left to right. And I'll go into more detail about why that is, but just be careful when you're using mnemonics or things to memorize things. They are very helpful, but they aren't always the entire story. And if you don't know the entire story, it's easy to get lost or make mistakes. So let's take a deep dive into each of the operations, and then we'll do some examples. Okay, let's zero in on our first operation, which is parentheses. Even though the word parentheses is used, what we're implying is anything that groups expressions together. So that's not limited to just parentheses, but parentheses is a nice way to start off the mnemonic. This is what I mean when I say they're great for memorizing, but they don't tell the entire story. So parentheses group things, but brackets also group things. Braces group things. Radicals group things. Absolute value bars group things, and fraction bars. And I'm just going to write it like this so you know that that line is saying fraction bar. All of these group expressions together to say start here. So when you see parentheses, I don't want you to assume parentheses is the only thing it's discussing. It's discussing parentheses, brackets, braces, radicals, absolute value bars, and also fraction bars. Next up, we have exponents. Exponents are pretty straightforward. It just means we have some expression or some number, something that has an exponent. So that's our exponent. That will be taken care of second. What I want to point out is one of the biggest places in order of operations, exponents causes students to lose points. That's the difference between this statement and this statement. The first statement here, you would need to use order of operations. And if you start to picture things differently, you see how they work. That negative is the same thing as -1 times x squared. So by order of operations, I would need to do the exponent first, which is square whatever this guy is, and then multiply it by -1. Over here, the parentheses are implying that this negative x is one number, and I'm squaring that. So this is telling me this is the same thing as -x times -x, which is what it means to square something, multiply it by itself. But a negative times a negative is a positive. So this ends up being a positive x squared, but over here we get a negative x squared. And I'll do it with numbers so you can see. I have negative and then 2 squared. By order of operations, I have to start by squaring the 2. And so that negative would still exist, and 2 squared is 4. And -1 times 4 is -4. But if it said in parentheses -2 squared, the parentheses are implying that that is now -2 and to square it. So that's -2 times -2. A negative times a negative is a positive, and 2 times 2 is 4. This case comes up a lot in order of operations, so please be careful. Next on our list is multiplication and division. Multiplication and division are performed left to right. Now let's talk about why they are performed left to right. Division is multiplication of the reciprocal. So all division problems can essentially be written as multiplication problems. And because of that, how do you differentiate who comes first if I can always rewrite division as multiplication? Because of that, we treat them as one group, multiplication and division. Another way to think of that, if I have A divided by B, B not equal to 0, that's the same thing as A times the reciprocal is 1 over B. Division can always be rewritten as multiplication. Therefore, when we see them, we treat them the same. So left to right again means whichever appears first is performed first. Last on our list is addition and subtraction. similar to multiplication and division. They are performed left to right. And the reason is because subtraction is addition of the opposite. So every subtraction problem can be rewritten as an addition problem. So if I have a minus b, that's the same thing as a plus negative b. So if subtraction can just be rewritten as addition, then we have to treat them the same way. So again, whichever appears first is performed first. Okay, we'll get into some examples to finish off the video. We are asked to simplify 5 minus the quantity 4 plus 3 squared times 2. So I'm going to look for any groupings. Here is a grouping, so I know I'm going to start there. So 5 minus 4 plus 3 is 7 squared times 2. I don't see any other grouping, so I'm going to move on to exponents. I see an exponent here. 7 squared is 49, so 5 minus 49 times 2. Don't see any more exponents, so now I can move down to multiplication and division. I have multiplication here, so that's the next place I go. 5 minus 98. I'm left with only subtraction. So 5 minus 98 is negative 93. And that finishes that problem. Before we get started on this one, I want to show you why fraction bars are treated as parentheses. Fraction bar or division bar is just division. This is just saying the numerator divided by the denominator, which means everything in the numerator has to be grouped together and divided by everything in the denominator. So that's just a visual so you can see why fraction bars are the same thing as parentheses in order of operations. Okay, let's get started. I have a grouping here. 8 divided by 4 is 2. So I've got 2 cubed minus 1 all over 2 minus 1 squared. I know a fraction bar is a grouping, which means I need to do everything in the top and everything in the bottom separately. So I'm going to look at the top, and in the top I have an exponent. 2 to the third power is 8 minus 1. And I'm going to go to the denominator. I have an exponent. 1 squared is 1, so this is 2 minus 1. In the numerator, I have subtraction. I don't have any multiplication or division. I don't have any addition to go left or right. It's just strictly 8 minus 1, which is 7. And in the denominator, I have 2 minus 1, which is 1. 7 over 1 is 7. And that's the answer to this expression. All right, we have a new expression to simplify. Let's start by looking for any groupings or parentheses. We have a grouping here that we need to address first. This is not a grouping. This is just telling us that it's -2 that we're squaring. Okay, so inside my grouping, I have to follow order of operations as well. So inside my grouping, I have an exponent. 2 cubed is 8 plus 1. So divided by 3 times -2 squared. I'm still in my grouping because I have multiple operations. 8 plus 1 is 9 divided by 3 times -2 squared. Square root of 9 is 3. So now I have 3 divided by 3 times -2 squared. All my groupings are addressed. Now I have to look for exponents. So here I have an exponent. -2 squared is +4. Now I'm left with division and multiplication, which I perform left to right. Whichever I see first, I perform first. So 3 divided by 3 is 1 times 4, and 1 times 4 is 4. And that completes that expression. We've reached our last example to simplify. So we've got pretty large expression here, and we're going to look for our groupings. I have a grouping here, and inside of that grouping, there's a grouping. But remember, once we identify a grouping within it, you go in order of operations as well. So inside this grouping, I know I start here with 10 divided by 2 is 5 squared divided by 5 minus 1/2 times 4. I'm going to stress again, this is not a grouping. This is multiplication. Two numbers next to each other and the numbers are in parentheses is just multiplication, not a grouping. A grouping means there are operations inside the grouping. All over absolute value of 3 minus 6. I'm still in this grouping. I know I have to address this exponent here. 5 squared is 25 divided by 5 minus all over absolute value of 3 minus 6. 25 divided by 5 is 5 minus. Now that I've addressed all of the groupings in the numerator, I can move on to multiplication here. 1/2 times 4 is 2. I have a grouping in the bottom because I have absolute value there. So that's going to be absolute value of -3. Absolute value of -3 is 3. So this is 5 minus 2 over 3, which is 3 over 3, which is 1. I hope this was helpful with you in understanding order of operations. Remember, you are magnificent, you are brilliant, and I'll see you in our next video.